Hi, everybody. Welcome to ChatLoopBackOff, where CNCF Ambassador explores a project for the first time with you. Today, on episode 67, we're going to be talking about Kserve, being explored by Shivay Lamaba. I'm your host, George Castro, on the CNCF projects team. And I'll be here with you in chat, so you feel free to ask questions. You can start with letting us know where you're from in the world. That's always interesting. And I will be here in the background so please add any questions that you have in chat and we'll address them. This is an official CNCF live stream, so please abide by the CNCF Code of Conduct, be excellent to each other. And Shivay Lamaba, please introduce yourself and take it away.
Yeah, again, thank you so much. And I'm really grateful to be able to come back on another live stream for the show. And last time it was a lot of fun, and it's a great way for anyone to be able to get exposure to different or to new CNCF tools. It's a way for you to learn how to approach a new tool, because there are so many open source projects within the entire CNCF landscape that it can be very easy for people to get overwhelmed. And this show is a way for you to see that if you are new to a open source project or a CNCF project, how you can navigate around it. And there's no script or pre-script available for this show, and it's all about just going out there and trying out things. So if things work, that's great, but if things break, it's a lesson for myself and for the audience as well. So, just a quick introduction, I'm Shivay. I'm currently a CNCF ambassador, and I've also previously been a maintainer for projects like Wasm Edge and Meshri, and I'm also contributing to some of the newer open source projects within the CNCF, including Kubeflow as a Google Son of Code mentor, and also I'm an active contributor to GitOps. So, a lot of my contributions have primarily been in the space of machine learning. And when I got the opportunity to talk about Kserve, it was very interesting because I have kind of played around and have, of course, contributed back to Kubeflow, but I've never actually tried Kserve myself. So it will be fairly interesting to see how all of this kind of comes together. And we'll learn about what is Kserve, and we'll try to explore, what you can do with Kserve. So it'll be interesting to try experimenting, because of course if you talk about Gen AI adoption, it's growing pretty quickly, and we are of course no stranger to adoption of Kubernetes and AI when the world's biggest AI companies like OpenAI, or even biggest companies like Apple, they're actively using Kubernetes for ML inferencing. I think it just goes on without saying that Kubernetes will become the de facto platform for being able to run large scale AI models. And I feel that with Kserve, that could be a potential opportunity. So, with that in mind, I'll quickly share my screen and let's get started. So, I'll go to the Kserve homepage. So, that's Kserve. And again, the way that we go about uh, this entire process is that we'll just specifically talk about what exactly can we infer from Kserve, and how to get started, what are some of the things that Kserve is really great at, and we'll explore it together. So if you have any questions or doubts, do share them. Now, I'm not an expert in Kserve by any means, and we'll try to figure out these questions that you might have together. So yeah, without further ado, let's start. So as you can already read here, that Kserve, it says that it's a standardized distributed generative and predictive AI inference platform, which is built on top of Kubernetes for a multi-framework deployment. So we can also like already make note here with this, that why Kserve. So it says that it's a single platform that unifies generative AI and predictive AI inference on Kubernetes, and it's good for quick deployments, yet powerful enough to handle enterprise scale AI workloads. Now, if you're already not aware, when we talk about the entire landscape, and for that, I think like, I'll just open up Excalibur. If you think of Kubernetes as a platform, one of the things that is relatively interesting to know is, and this is something that has been there for a while, but if you talk about like within the entire landscape of Kubernetes, and you talk about a pod right within a Kubernetes. If I'm just like drawing one single pod here, so if I just okay, there's something wrong with this. But anyways, if I talk about like a pod right now, normally you could run have a CPU with a pod, but of course with Kubernetes we also natively support GPUs. And just with Kubernetes 1.34, if you're not already aware, so Kubernetes 1.34, there's something called as DRA, which is known as dynamic resource allocation. And it had been in beta for a while, for last 3 4 releases, and now it is finally um, GA. So it's generally available with Kubernetes v.1.34. And what that means is that if you're willing to dynamically allocate GPU resources, or even like FPGAs, or I mean mostly it's going to be really useful for GPUs, that you can dynamically allocate them based on the requirement. So, for example, some AI models might not require you to have more than one GPU, but some large scale LLMs might need more than one GPU to run them in batch, or probably like run them parallelly together across multiple pods. So you can dynamically allocate them. And the need over here is that different AI workloads require different compute. And in order to efficiently use your GPU workloads for Kubernetes, you need to have the capability of being able to like dynamically allocate them based on what's the current workload that you're facing within AI. So I think we are really seeing a lot of open source projects within the Kubernetes ecosystem that are purposely built for AI inferencing and running AI training. And of course, with 1.34 now, it's going to be even more flexible to add that. So that's really unique to see that, Kserve as an open source project gives you the capability of being able to do inference. So primarily it serves that purpose. Now, coming from a Kubeflow background, so if you're already not aware what Kubeflow does, I would like to just probably talk about Kubeflow for a while, because Kubeflow as an open source project is also built on top of Kubernetes. Now, that what that means is that it allows you to handle an end-to-end machine learning lifecycle. So starting from your model training, where you can define an entire pipeline which allows you to do all the way from training to serving. And then notebooks is like a Jupyter notebook or a Google Colab notebook that allows you to run your workloads. And then you have like Katib for hyperparameter tuning. So whatever you can think of, even in fact you have the Kubeflow model registry where you can store the OCR artifacts, which are your packaged models, into the model registry, and then you can use that across your entire for whether it's for inferencing. And what's interesting is that Kserve has a built-in. You can say that it's probably an integration where for inferencing part, Kubeflow actually uses Kserve as a project. So that's pretty interesting to see that if you want to do, if you have already trained your model, it's ready to be deployed and you want to serve it now. So Kubeflow internally will use Kserve. And that's like one of the great things about the ecosystem, is that there's a lot of dependencies that are overlapping. So if you're trying to build like an end-to-end machine learning lifecycle, you can use a lot of the components from Kubeflow, but then you can use Kserve for the serving part. So that's pretty interesting. And the good thing over here is that, of course, with AI models, you want them to be having GPU acceleration. So that is why I just wanted to talk about that DRA aspect, because I feel that now you could potentially alongside and then you can get things like model cache, especially if you're trying to reduce the loading time. So rather than having to download the model again and again for every single request, you can cache the model locally, and this reduces the loading time and just gives you instantaneous responses. And then you can do things like advanced cache offloading. So that's also a fairly interesting point about how you can manage memory with KV. So because KV lookups are fairly quick, and you can use that to offload to do like longer sequence actions. And of course, considering that it's based on top of Kubernetes, so you get native auto scaling. And the great thing is that if you're already not aware, Hugging Face is the largest online repository of open source models. So it has built-in integration or support for Hugging Face. So you can very easily just take an off-the-shelf model from Hugging Face and start to use it. And it supports multiple AI frameworks. So of course, PyTorch, TensorFlow, these are all open source frameworks or libraries with which you can create machine learning models from scratch. and you can do deployments either with canary deployments, or you can run full scale pipelines. And there are also dedicated advanced monitoring. So the great thing about being able to do things like outlier detection or even drift detection is that over time, as a model goes into production, there are a lot of scenarios where the uh, because the model has never been exposed to a lot of the production data, the quality of the model might degrade, because internally the way that data drift or model drift essentially happens is that your weights have been, like, let's say, trained upon a large amount of data, and you used an algorithm, like a statistical algorithm, like calculating the mean of the values. So gradually you'll see that as your data set in the production also changes, that shifts your median or the mean that you're calculating, and that results in drop in accuracy that you're getting from your model. So it's great that Kserve has a built-in way of being able to do that detection. So that's great. And here we can see that how we get this really simple API that we can use. So we get a custom resource definition, so which means that with Kserve you get this CRD, like the, and if I'm not mistaken, so you can see here that this is, like, I guess, one of the CRDs, which is the inference service. So you will basically write the YAML, and Kubernetes Kserve controller will do the work for you, and it encapsulates the entire complexity of the networking or scaling. So if you were to do this manually, you could have done this manually with Kubernetes as well, but you would have to manage the auto scaling and networking. You'll have to set that all of it up yourself. But the great thing about Kserve is that it all automatically encapsulates that for you, and you can still use the standard Kubernetes API with the controller that's available for you to use, and you have ability to roll out canary deployments. And here you can see that this is one of our CRDs that we are setting up, which is essentially, what it's, I think, doing is that here you are defining a model serving endpoint where you define the CPU and the memory required, and then what's the model that you're using. And then I guess the storage URI, it basically refers to where the model has been hosted. So in this case, the model is hosted on Hugging Face. So you can really use whatever storage URI you want. So I would imagine, like, you can use things like Jozu Hub, or maybe Docker Hub, wherever you're storing your model as a containerized artifact. So that's good to see. And here is a diagram of essentially how Kserve works. So let's have a quick look into what's actually happening. So we can see that there are essentially these 5 different layers, or I would say 6 different layers, where we have pre-process, predict, generate, inference graph, explain, and monitor. And then we have the predictive and generative model inference. We have Knative plus Istio, which is our service mesh layer. And of course, beneath is the Kubernetes. And then, that's the CPU and GPUs for the pods that we are running. And we have the model storage. So what we can probably see is that um, we have, as the predictive and generative model inference, it says that it has a Triton inference server, or it has support for like VLLM, serve runtimes. So we can probably think of this as, like, let's say, the control plane, because it handles your model storage, and it also handles the rollout strategies. So that's a good thing. And then we have all of these different serving runtimes that you see over here, including the model storage. So your storage could be on any type of object storage, or, like, let's say, GCS, container registry, or maybe Hugging Face. So it'll be able to, like, pull your image from there. So you can see that this is the kind of an architecture that we follow. So the control plane allows us to manage the life cycle of the model. Then the data plane provides us, um, so it says that it provides us a standardized inference protocol for model servers supporting both predictive and generative models, which means that it's, in a way, like, um, the execution part where the model is basically now loaded here, and the requests go from there, which includes, like, the predictor, or maybe, like, there's some transformation happening, and it will communicate via the standard API. And then we have the inference service, which kind of handles the actual CRD, which simplifies the model deployment. So that's a good thing. And then one thing that I think we are coming around for the first time is this inference graph, So it says that it enables advanced deployments with pipelines for preprocessing and ensembles and multi-model workflows. And then the next step is to basically get started. So this one talks about how to install Kserve and the dependencies on a cluster. So what I'll do is I'll open up Docker as well, and we can try to do that. But let's take a look at what it's basically doing. So it's showing us installation process for Kserve. Then we go ahead and create an inference service, and we send this request. We send the inference request, and we also have some detailed guides. So we can also probably go into that. In fact, like if we look at the deployment, you can see again pretty much what we covered. We can just quickly see if we uh, missed anything from this getting started guide. So yeah, Gen AI. Yeah, I think we have already covered all of these different things. I would like to probably go a bit deeper into this inference graph, because this seems to be very interesting to see that you can chain and ensemble multiple models. Here, that's not limited to having a single model making an inference. You can also essentially chain and have multiple models together to define these workflows. So that seems to be pretty interesting, and I'll just quickly take a look. The questions are, so Kafka Talmud is asking, can we run Kserve offline? I think so we can, because it seems that you can run this on Kubernetes. So we'll try to do that. I'll be trying right now to run this completely offline, and this is like a more deeper architectural overview. So we have the CRDs for managing the lifecycle and the chaining workflows, and we define a cluster-wide model runtime, and then we have the model storage that we'll use. So I think should be good. We can probably start with the installation. So that's the quick start guide, and I'll make sure to run everything. So let me open up a terminal window. So let's go ahead. Okay, so right now, um, let me just quickly check if I have kind installed. I'll just ensure to create a new Kubernetes cluster, because one of the prerequisites is to have kubectl and have at least one Kubernetes cluster. So let me just cross check if I have everything set up. And in the meantime, we can also explore what other things we need. So we need kubectl, we have Helm, and we have curl, and we can use either an existing cluster or kind or minikube. And then we have a standard deployment and we have a Knative deployment. Oh, that's good. I mean, would love to probably see if we have any documentation on what's the difference between the two. Maybe like we can just search online. Difference between Knative and standard deployment for Kserve. That's pretty interesting. So it says that Knative relies on the Knative serving, which supports things like scale to zero, whereas the standard uses standard Kubernetes resources. Okay, that makes sense. So depending on your use case, you might want to like pick up one of these. We can probably go with the Knative one and try to use that. Okay, so if I just take a look, so our cluster is running. Let's proceed now with setting up, and let me also just cross check if I have Helm installed. Okay, perfect. So I think we're good to go, and we can start to run this deployment. So I'll run this curl command and hopefully everything works. So one of the things that we saw earlier was that we are seeing that it's using Istio. So Istio is being used, if I'm not mistaken, for our so there is an Istio that's your serverless or the service mesh layer. So I think like that's one of the reasons why it is gateway for all of the networking and the serverless capabilities or the service mesh for like looking at your load, because as we saw is um, having the capability to also auto manage all of your scaling networking. So that's one of the reasons why we are seeing built-in support for the Istio, because handle all of your scaling, networking, and you don't have to put that out manually. So we can see that it installed Istio. We also installed the gateway, or the ingress gateway from Istio, and it says that we successfully installed, but I think we're still not quite done. We're still probably waiting. Also see that if it has created any images. So do we have any active running? So yeah, we have the kind cluster running right now. I don't think we have. All right, let's probably wait for a second. So while that is doing, we can probably go back and talk about the quick start. So as soon as this gets done, hopefully, if everything is working, then we should be able to see the two different things, which is the case of controller manager and the case of local controller manager. So these are the two things that should be there. And we have guides around running like a GenAI inference service or running a predictive model. I would like to see the difference between the two. So GenAI, as it suggests that it's mostly going to be like a LLM model, but I would like to also see what's the difference between this and prediction. Because if you think of it in this way, that before GenAI really took off, we had a lot of work on core machine learning models, and you could also run core machine learning model inference with the help of Kubernetes. And this seems to be the case that this one is probably meant for AI models, which are not necessarily like Gen AI models. So in this case, you can see that we have an example here with the Iris, or this sklearn, which is a machine learning model. Scikit-learn, this is a very popular machine learning library, and they have trained a really simple, I would probably guess that it's like a Canon model that we are using for doing the inference over here. So, of course, the amount of CPU and the usage or the GPU will be a lot less, considering what kind of model you're using. So, in this case, also, like what we're doing is we are creating the inference service and we are checking the status. We can get this both in YAML format, or we can get this directly. We can apply this, and once you apply that, you can of course set the ingress port and set up the load balancer, or if you want to port forward, you can also do that, and then you can perform your inference. So looks very similar to what you would also do with a typical Kubernetes deployment. Because if you look at, like, let's say, deploying an AI model with just pure Kubernetes, because one thing to remember is that you can still do Kubernetes with AI, or you can run. So if I just open up this particular article here, they have gone ahead and created a deployment YAML which contains the actual model itself with the image of the model, the container, and they apply the deployment and they expose it. And then they have a dedicated command to put up an horizontal pod autoscaler, and I guess like they have to do all of this manually. And with Kserve, the good thing would be that you don't have to manage all of that. You just run a few of these commands and you're good to go. So I think like that's probably one of the reasons. And we have added, so let's go back to the quick start guide and we'll just verify that Kserve has been installed. Okay, so we see the Kserve controller manager, but I'm not seeing the local model. That's interesting, because did we run the same command? That's a bit interesting, because let's see. Okay. So we are getting one thing. I'm not entirely sure why is this not showing up, but maybe if we try now to go ahead and run, like let's say we can try out our first ever. Actually, before GenAI, I would probably like to test the regular predictive service, because I would imagine that having a large model like Quen, it might take a while, and it clearly requires you to have more resources. So let's first start with a bit something somewhat simple, and let's try this out. So this says that in this tutorial you will deploy an inference service with a predictor, uh, and you must have that loads a scikit model, and this model has three output classes. So if you're not already aware, it's one of the most classic data sets that's available. So that's called the iris flower data set, where you have three different kinds of flowers. All of them have different shapes. So our goal is to be able to like classify one of these, that for a given image, which particular class does it belong to. So running that kind of an algorithm, that's like number one. So that's the iris flower data set. And then we're going to be like using that here. So before getting started, we have set up the quick start guide. So that's good, which means we already have Kserve running now, hopefully. And then the next thing is to create a namespace for this new project. And next we'll create the inference service. So if we look a bit carefully here, you can see that we are using the sklearn model. If you're already not aware, like, so sklearn provides a bunch of pre built models or even pre-trained models, and we are just simply going ahead and providing the number of resources, the amount of RAM or the memory that you need in order to like set this up. So looks fairly straightforward, and we can go ahead and run this. So let's go back. Okay, so we have created that. Hopefully everything goes according to the plan, and we can check the status of our inference status. Okay, so we see the inference service over here. Although I think we are still kind of missing a few of these things. So the only thing that we see right now is it's not even ready. So we might just want to cross check. Okay, so we are getting an internal server error. So it's saying that connection refused, and yeah, we can see there's nothing showing up right now. If I just do a kubectl, yeah, there's nothing showing up. Maybe just okay. That could be probably one of the reasons where we are not seeing. So normally we should see the local manager as well. So there seems to be something wrong with. You might just have to double check why is it just showing us the controller manager but not the local model controller manager. Or maybe we can try the standard deployment and see if that helps us in any way. Okay, we do have Helm. If I just try this again, okay, there's some issue with that, but okay, then let's just try Knative again and ensure that it added actually everything correctly. Might have missed something. Okay, so it's still there, so that is fine. Then just double check one last time. But that's a bit interesting to see that it only has this. Right. And if I just try to run that command again, we can just double check here. Yeah, so it's still pending. That's the current status. If I run this the inference status again, yeah, that seems to be. You try to just ask. Could be the issue. This we can see that there is of course no pod being created right now for, and we are using Knative, so it's looking at the Knative serving, and you can probably see that the inference service is not ready, and might just have to take a look. Okay, so it says that, oh, it's because, oh, okay, got it. So it is because of a Kubernetes versioning change. So our cluster is running version 1.2.7. So yeah, maybe we can replace and update the version. Hopefully that could get things done. Yeah, this is a classic issue. It's good to see that. The good thing is that Knative, you should always ensure that your Knative serving and your cluster that you're running, it's always on the same version. So always just make sure to handle that capability. Otherwise, you'll run into incompatibility issues with your Kserve serving or the Knative serving with your Kubernetes cluster that you are running locally. That's one thing to then, I guess, keep in mind. Let me also just cross check if we have any further questions. Okay, so right now I don't see any further questions, so that's fine. And we'll just try to ensure that this works. So hopefully this should patch the request and you should be able to get the pods, hopefully. So let's just cross check that. So we'll just describe. Okay, we still have to. Okay, it's showing an incorrect room. Maybe in the worst case, what we might have to do is install a later version of Kubernetes that is compatible with the Knative serving and then try the same approach. And again, that's something that, again, this is not scripted. I didn't have a pre-written script. So that's good to know that what are the kind of errors you might run into. And it's also a great way to for us to understand. Because I just feel like if you have already done any type of ML deployment with the help of Knative or with the help of Kubernetes, you still are following everything, but it's able to abstract out a lot of the other things that you've probably had to handle. Maybe it's auto scaling of your pods, or maybe it's the networking part, like setting up Istio yourself for the service mesh aspect. Like all of that is taken care and handled for you when you're using Kserve. So like that's at least an interesting tidbit to kind of remember, that you can manage all of that with the help of Knative. So let's just probably try this for the one final time, and if it is working, okay, so let's see that now it seems to be working. So it shows that there are two, okay, and then there's still some ingress configuration issue, so you might just have to fix that. So there's still some filling issue of the Istio. Hopefully we can also fix that, because this is where all of the actual networking part with the help of the Istio controller or the gateway, that's basically coming to picture. So I suspect that because of the incompatibility of the Kubernetes cluster version, it might have led to this. So hopefully that gets resolved. But in terms of the steps, so we can see that once we apply this case of implementation, where we also provide the storage UI for the model, then you can just use kubectl get inference services and show you the current expected output, and then you apply your ingress IP, and you can either have a node balancer or node port or port forward. Usually I like to go with port forward, and then you can run your inference. And apart from that, you can also run some performance tests, which is always good. And then of course you have like a Gen AI. So hopefully, okay, so it says that everything is supposed to be fixed. We can go back and just cross check that. So we'll go back to just a regular inference service, and we can just check the status. Okay, so now we can see that it's true, and we have the latest ready version. And I just want to cross check once. Do I see the other aspect? Because it could have been because I was using an incompatible version. Hopefully we should see both the controller manager and the local model. Okay, we will still see that only, but let's see. That's something that I have to probably figure out why we are not seeing that. So going back to here, I'll also apply this so that our cluster is running that supports the load balancers. So right now it is in a pending state. And then if you want to apply port forwarding, we can do that. Then you will have to open up another terminal. So for this, I will open up another terminal. I'll log into my cluster. So give me just 1 second. Oh, actually, I can do that locally. My bad. Okay, you can ignore that. Second, okay, so in another, let's look at what it says next. So another terminal, you should be able to like run this to enter this to perform the inference. So let's try that. Okay, so it says curl. Maybe there's something wrong. So let's just run all of these one by one. And then we have service host name is this, and then finally the curl request. So it says fail to open iris input.json. Now it's interesting. So how should we get this iris input.json? I think that's probably, so we're missing this last thing that we can see, that it has to be the iris input.json. Let's take a look if we have an example of Kserve. Okay, maybe we can store one of these. So I'll have iris input.json. Perfect. And then if I go ahead and run the same command, it says localhost 8080 was resolved, post connected to localhost 8080. It says internal server error, connection to, okay, let's take a look at what might have been the reason. So let's try to run this again. And we're still getting the same connection error. So might have to cross check. And by the way, I think so there are a few other questions, maybe like we can come back to those. So that's interesting that we might want to just probably like run this once, perform the inference. So let's try this out. So this is an example of the, okay, you're still getting, okay, this time it's connected to port local 8080 and connection of here. Okay, so we are getting a prediction. Perfect. So we are, I think earlier there's something wrong. Maybe like the Ingress gateway that we were setting up might not have completely set up. So now we have the Ingress gateway service, and so this looks to be good. So we are able to make a prediction. So that's great. So this shows that now, depending on the setup, so for example, if you had a real DNS, then you would be able to like directly curl the inference service with the URL. And if you want to like run a performance tests, you can also do that. And if you just look at the case of concepts, right? So we did look at the architecture overview. Maybe if they have a diagram, that would be good to know. Otherwise, yes, as you saw that there are essentially like these two main points, which is the control plane, which manages your inference services, inference graphs, and the resource orchestration with Kubernetes APIs. So all of the CPU, GPU resource, all of that management that you're defining inside of your inference service, all of that is managed with the help of the control plane. So not to get confused with the Kubernetes control plane. And on the other hand, the data plane will execute your inference requests. So that's where the actual networking part of with Istio, that's what is probably getting control over there. So if we go into, okay, that's the architecture. So yeah, you can see here that, for example, we were specifically looking at, um, we can look at the case service, the generative inference service as well. So here you can see that we have the Envoy AI gateway, and that's kind of an AI gateway will take care of rate limiting, applying some kind of RBAC control, and built-in observability for LLMs. And here we have our case of controller, where we have the inference service, and the inference service will have a VLLM container. So that's because we have different support for different type of backends that you're using for your LLM. In this case, we have an LLM example, we have a VLLM example, and we we can like basically see that how the case of controller will manage lifecycle of the inference services. So that's an interesting thing to see as our data plane. And if we also like take a look at the control plane, hopefully we can see a good diagram to compare it with. That's our architectural diagram of deployment with Knative. So we are, I think, using Knative, so this might be the one for us. So we have all of these built-in components that provide you the auto scaling and the serving of these, and internally you're using Istio for the networking, and you have the Knative gateway. That's pretty interesting to like see how everything kind of works. And then one thing that I'm more curious to kind of see how everything is kind of working is, so we came across this particular term, which is an inference graph. So I think inference service is pretty self-explanatory. So the goal with the, so if I go here, so we have, yes, so within Kserve we have something called as, because it's a CRD, so we have, Kserve has its own CRDs that basically declare how the model serving would basically work. So in this case, we have the inference service, which has the main abstraction for deploying the models. That's what we already saw. We actually applied an inference service, and we applied that for our case of cluster for doing the inference. And then our inference graph is what is allowing for the multi-model inference workflow. So the idea here is that you could chain together multiple models. So you'll have an inference service, then you'll have an ensemble model. So it's made up of nodes and the routing steps. So that's pretty interesting, because if you have a much larger project, and which basically means that you're not just reliant on one single model, but you're probably like passing the results or the predictions of one model to another, or you could combine predictions from multiple models together. So that's also pretty interesting, like how it routes your request based on the request volume. That's pretty interesting to allow users to have like multiple steps and then accurately just work on that one. So we have, that's our inference graph. I think we can probably take up a few questions now. So Hemant is asking, how does Kserve fit into a CI/CD and MLOps pipeline? So I guess my thoughts behind that would be, and we can probably explore that in terms of, because it's running on like regular Kubernetes. So it's pretty interesting to like think about this, because you can probably say that if you are pushing an AI model, so in this case, like a machine learning model, and you want to package it first. So maybe you are using like Kubeflow, or you're containerizing the entire application with Docker, right? And that would be our CI/CD flow, uh, or the MLOps pipeline. For MLOps, you can specifically like think of Kubeflow, because Kubeflow is an MLOps platform, and it's one of the largest projects that is there within the entire Kubernetes ecosystem. And Kserve is essentially, if you think of in this way, like let's take a look at a Kubeflow architecture, right? So let's take a look at the ecosystem here. So we have, like, let's say this is our entire idea. So for the case of, we can see here that this is all of the different components that you get with Kubeflow, and the different projects that you'll use for each one of these steps of a AI lifecycle. So if you think of the easiest example of a lifecycle, it's data prep, and then we have the model development, and we'll store the model after we have trained it or we have fine-tuned it into the model artifact. And the ML metadata in the model registry contains all of your hyperparameter tuning. And once the model is ready to be used, then you would use model serving to run the inference of the model. And then you have some online feature store that stores features about the extraction. And that means that if you were to apply an appropriate Kubeflow project over here, so for model serving, you'll use Kserve. So Kserve is being used at the, I think, at the end, where you want to have proper observability with your model being served. So you create an inference service, you deploy it, and then you can serve your model with the help of Kserve. So that's probably like the answer to your question about what where does Kserve fit into a MLOps pipeline. And maybe, once you have run your CI/CD tooling, if everything works, if the uh, model has been securely accessed by the container registry, then you can always use anything else. So I hope that answers the question. And then uh, Abu Talib is asking, I hope I'm pronouncing that name correctly, what AI tool did we use to get the recommended fixes for issues faced during this case of deployment? So I'm using something called as Warp. It's an AI tool. Now, normally, you could also use something like, so there is like Kate's GPT. So that's one of the open source projects that is available today that you can leverage. And if I'm not mistaken, I think KHGPT is actually also part of the CNCF landscape. I might be incorrect. Let's take a look. Yeah. So you can see here that it was accepted to sandbox level in 2023. So KHGPT, the way that it works is that it deploys an agent that understands your entire cluster. So it will look at all the resources, namespaces, and the services that are deployed. And you can essentially, like, if you're finding it a bit hard to debug your cluster, it will take a look at the entire architecture and all of the things that are actively running in your cluster, and it will be able to uh, you know get you um, it running, and it will be able to like suggest you fixes that you can make. And the great thing is that you can like really just use KHCPT with any type of Kubernetes cluster, and you can run it and deploy it with your use case. And then Hemant is asking, what kind of metrics are exposed by Kserve, and how do you integrate them with Prometheus? That's a good question. Let's explore that ourselves, because of course with Kserve or any other tool, we want to have like the core of this is that we should get appropriate metrics. So we can probably look at docs regarding Prometheus, autoscale. Let's see. So we can see here that it says enable Prometheus scraping annotations on pods, and we are getting things like, okay, so if it's true, then Prometheus annotations are added to the inference pod. And let's see. So what are those specific? The question is like, what are those specific metrics which get exposed? Do we have an example here to tell us about that? Or maybe we can ask Google AI search. Oh, my bad. Didn't copy. But I would probably argue that in terms of what would be like typical things like the latency, throughput, which are I think, standardized across everything. Um, so I think that's what we saw actually, that the previous documentation which allows us to set up our architecture. So they would like to get that discussed. So if we talk about Prometheus, yeah, so we have to enable this Prometheus scraping so that we can send the logs back to Kserve, or sorry, back to Prometheus from Kserve. And normally, it would be from the V1 metrics. So that would give us the metrics, and mostly it's the latency, the throughput, and how much utilization. And the reason why we want to, look at these two numbers, especially the first one, the fourth one, is that latency, if you're taking too much time, because the request latency means that your LLM or your AI model is taking too much time to give you a response, and there could be multiple reasons. It has failed, or it's just terribly slow. And then GPU utilization is also extremely important, because uh, how much effectively you're using GPU, that matters a lot. So that's something to probably keep in mind. So those are some of the different metrics that you are getting with Kserve. Hopefully, that answers your question. If there are any other questions, we can probably then try one last thing, which is a deployment of a. I'm not sure how much time this might take, but we can take a look at deployment of a GenAI service. So maybe we can create another, because I think we already created this. So maybe like we can create another namespace called Kserve test Gen AI, and we'll copy this over here. In this case, we are also providing a Hugging Face model, and we'll say apply knet Kserve test Gen AI, and we'll give it the namespace as Gen AI. So that's created, and we will apply. And then we might need to authenticate with Hugging Face. So that could be a situation, because I'm not sure if I did, but we can take a look here. So of course, okay, so we get inference services Quen LLM not found. And that's probably because, okay, oh, my bad. So it's not ready. And the reason could be because we are not authenticated to Hugging Face, which is insufficient memory. Okay. So we might have to update or increase the memory in that case. And these are things, right? So you saw clearly that in one example, because we had a really simple model from sklearn, which you can literally run on even a small edge device, whereas a Quen model that requires you to have at least 2 GB. So again, that means that we might have to limit the amount of, but then that might lead to a bottleneck. So we might have to like create another uh, entire model so that we can have the support for the required amount of memory that we have requested. So I think like that's something that we can do, and of course you can follow this and ensure that you can change the request. But let's also just take a look at some of the other things that we have over here. So of course you have your entire Swagger UI, which shows you the list of all of the models, and if you want to interact with the inference service, all of the new models that are there, endpoints that are there, so you could use that. And then you've already kind of covered the model serving. I think from an administrative guide, I'm not sure if you have gone too deep into it, but this primarily like talks about, yeah, the generative is GenAI based, and then deployment. So you can see that, yes, for the question about how you can deploy Kserve, you can deploy it with standard Kubernetes, or you could also deploy it with Knative. So it uses the Knative to provide the auto scaling. And then you set up the networking to set up the gateway API. But yeah, Looks like we are also running out of time. If there are any other questions as well from anyone in the chat, otherwise we'll also just try to, I guess, I don't want to limit here, but yeah, uh, the thing is, like the rest of the steps would pretty much be the same. If you run into these issues, then you can try to, scale your cluster or add more nodes, like if you want to. But I think, yeah, that's pretty much it from my side. I think we were able to get at least like one example running, which I'm really happy. That was the predictive hair service, and you saw a clear difference between the size of the models, which was just a simple Skykit model, sklearn model, doing a basic object classification. And then we have, of course, the Gen AI. And even though it's a small model, that you can see that they require so much more memory. And had it been like, let's say, a GPT-5 model or a Llama 3.3 model, it would require even more amount of memory and amount of CPUs, maybe even GPU, because without a GPU, the inference might not be too quick. And then all of the auto scaling, all of that helped quite considerably. So yeah, I think we are good to go.
We are good.
Okay, I see one more question which is being asked by Hemant. In production, if Kserve model endpoint shows high latency during sudden traffic spikes, how do we diagnose and optimize it? So I think it's because you saw that when you are when you're implementing the or you're enabling the Prometheus serving, right? So you're able to send all of these logs. So you could look at a Grafana dashboard that's looking at your Prometheus metrics, and if you see a spike there, you could add a condition that uh, you should send an alert when your request is getting spiked. And then you might want to take a look at, okay, at that point in time, because it was coming through an inference service request, maybe you can take a look at the request workload. What was the request workload, and why, what caused that? You could take a look at the total GPU utilization as well, right? So those will be the things that you could use in order to take a look at why was there a high latency. And you could always also try to use like locus to do a real world simulation and try to like replicate the environment which caused that. But having this robust open telemetry collector for gathering all of this data from Knative should give you at least a very initial high level overview of what caused that particular spike, or what caused that particular high latency, while you were trying to like gather all of these metrics with either Prometheus or open telemetry.
All right. That's it. We're out of time. Thanks everyone for showing up, and I'll give you the last word and then we'll end it. Thank you.
Yeah, thank you so much again to the entire CNCF team for organizing this. And I think it's a really interesting space because, you saw that with case of being able to like deploy models, it becomes super easy, super simple. And you don't have to worry about your networking, managing all of your Istio. All of that is automatically taken care of and handled thanks to the data and the control plane architecture of Kserve. So I feel I would like to personally try to build an entire end-to-end machine learning project and use Kserve with the help of Kubeflow, because I am contributor to Kubeflow. So I think it makes perfect sense to also try out Kserve with Kubeflow. And yes, I'll be there on the CNCF Slack, and I'll make sure you can check out all of the other ChatLoopBackOff episodes, because they are great. They cover a wide range of different CNCF projects, and it's a great way to be able to like come out of that imposter syndrome that you might have, considering that you're looking at so many projects. And this happens almost on weekly basis, so you can take a look at all the upcoming projects also that will be covered in the chat loop back off, and make sure to also explore those.
All right. We'll see everyone next week.